then implement some advancements that are believed to be held in the future. The LCA study includes manufacturing phase and end-of-life phase, and the functional unit of the LCA is one PEM fuel cell stack, which has a electrical power output of 48 kilowatt. The eco design wheel is a relatively well-known concept. As you can see, it has 7 axes, which are divided into 3 product concepts, and it basically anticipates and minimize negative environmental impacts without affecting the product quality. So the quality of the product should stay the same, but the product should have a lower environmental impacts. So with this eco design wheel, we developed different product concepts together with industry partners and other project partners in eGHOST. As you can see, there's a 7 axes, but today we will focus only on end of life. So we will only focus on X1, X2, and X7. As you can see on those axes are highlighted with green boxes. So we will focus on the selection of low impact materials, the reduction of material usage, and optimization of end of life system. That will be our focus today. First, just how we define the current state. So the base case, fairly simple, just already with known technologies. So we have a lot of incineration, landfill, and open loop recycling. The open loop recycling means that the recycled materials from this project are used on other projects, or they are basically put on a market. Where the closed loop recycling means that we will use the same material in the same product, and in base case we don't have that yet. If you go further, we define the short-term case. Short-term case means that the industry believes that these implementations will be held in near future, in a few years. So we will kind of reduce and reuse the end plates, 30% of them. We will have a platinum recycling. Here we connected with Best for High project, but more on that a bit later. And the whole mass, the mass of all the components would be a bit lower, or at least some of them, and that also indirectly affects the end of life. In long-term case, the industry believes that in long-term these implementation are possible. So in not so many, it's in a few more years. Again, what I have to emphasize is also that the cases kind of builds up. So every action that we have in short-term case, we also have in long-term case, but we add something new. In this case, we add reuse of bipolar plates. So 30% of bipolar plates should be also reused in long term. That is what industry and we believe it could happen. Optimistic case, this is kind of it's really optimistic as the name said. So it's basically shows potential what can be achieved, but the industry it's not. We don't know if that's possible, but it has a potential to achieve it. So as you can see, we kind of increased the platinum recycling to 70%. Also increase the bipolar plates reuse to 2/3, and we also have a ionomer recycling, which is also held which is also being discovered or being worked on within the Best for High project. And the last case is a disruptive case. So disruptive as in sense that it will basically change the whole technology. So it will basically be a visionary concept. What could happen if we basically have some really worldwide development in the end-of-life technologies. So in this case, the whole percentages are higher, and we also have a current collector. We can also recycle current collector with a closed loop. Now, I mentioned we used the data, or we kind of connected the Best for High project within the eGHOST. So the Best for High project basically develops a recycling for platinum recycling within the hydrogen technologies. Within those, it believes that we can also recycle ionomer within the Best for High, and this is just a schematic what we achieved. And the point is that the environmental impacts of the recycling platinum are also lower than the virgin ones. Of course, this is just a bonus, because the main thing is that we have this circularity of materials. The recycling is now on just on a laboratory scale on TRL 5, and it shows a great potential even now without the scale up. And the University of Ljubljana is connected with both projects, so we are happy that we can be kind of a bridge which connects both projects, and I think that we can benefit. Each product can benefit from each other. So I think it's a great thing that we have made this possible. And now for the end-of-life modeling is kind of tricky because it's a critical phase. The end-of-life is a critical phase for modeling, and that's it because, in a sense, when you have a recycling processes, when you have a reuse processes, it's kind of end-of-life becomes also the manufacturing phase, because with end-of-life you basically create a new material. Unfortunately, it has the biggest uncertainty, mainly because of lack of data, because the end-of-life industry are not so developed yet. So we don't have many data from the industry. The databases are kind of scared on this topic, but yeah, we expect a big development in the future. And now in general we know that we have two recycling, a closed loop recycling and open loop. So we closed loop, basically the virgin materials are replaced with recycled materials within the product. So if we use some plastic in the product, then the same plastic will be recycled and used again in the same product. Therefore, we don't need any overhead impacts or nothing. It's pretty straightforward. But in open loop recycling, it's a bit more tricky, because basically the recycled materials are used in other products. So they're essentially put on a market and others can buy it and use it. So it's kind of tricky who actually should report those emissions. It's double counting can happen, but must be avoided. So we must be really careful how we model that. During the recycling process, it's really important the efficiency of recycling. So how many recycled materials can we actually gather from the material that is inside the product? And basically how we solve the double counting is that we separately report the end of life phase and separately report the double counting. So we just show the emissions of the end of life are those, and then if we kind of and this is absolute value, and then we show, okay, but if we would use virgin materials, we kind of save X amount of emissions because of the recycling materials. So that's from my side, really quickly, everything. And yeah, back to you, Mitya.
Yeah, thank you. Thank you very much for a brief presentation. Of course, it was a very short presentation, but you stressed out some, let's say, challenges with end-of-life modeling in LCA. So basically, at this point, I would like to thank also all partners from Best for High partnering project. As you heard, actually the wish or from clean hydrogen was also to somehow use results from let's say parallel projects in other projects. So I think that collaboration here is very fruitful because critical and rare earth materials are actually the most or on the really top agenda of European Union. So it is very important that we received in eGHOST the inventories and the data from real laboratory TRL5 recycling processes. Of course, inventories are still on the laboratory scale, so there is a gap to the industry level, but at least we have models that we will be able to let's say improve in the future and show even greater potential that is maybe on the laboratory scale where the maybe energy inputs are a bit higher. There are, if I summarize, gaps in databases, maybe not so much for the PEM technology, but it is quite critical for the solid oxide technology that is also very promising technology and also part of the eGHOST, but that may be for one of the next chats or presentations. As stressed out, the right approach in the end of life should be made, because it is very different when, especially in reporting, because it is a big difference when you have a closed loop that is relatively simple to model, and when you have open loop that you can avoid impacts in your product, but also avoid impacts in next product. So that can be somehow double counting, and we have to be careful reporting that. There is, of course, uncertainty arising from the definition of the product concept that were presented now. But I have to thank all the industry input, because we have very fruitful discussion, not just within the project, but also with all the industry connected to the eGHOST and Best for High, to establish at least in the short term, long term, and optimistic concept, some potential happening in the industry, how the industry sees that. On other side, of course, disruptive concept, that means that really the paradigm will shift in the future, and this is some kind of visionary one. But of course, we have to be visionary. We are already visionary if we are working in the hydrogen technologies. So we have to push even more to present that hydrogen technologies are really promising, and they will play a big role in the energy supplies of the future. At that point, I will thank you all to be present, and of course, I would invite you with some discussion, with some questions, if you have them. Thank you very much. Okay, it is one question or not.
Hello.
Hello.
It's for me. Well, I'm Javier Dufour. I'm coordinating the eGHOST project, and it's just to add some insights to the talk of media, because I would like to highlight that Best4High and also eGHOST are the first projects just looking at this recycling and introducing some sustainability aspects in the design of these products. In this way, we are opening the way to get more environmentally friendly products. Of course, hydrogen is, as a product, is a very good alternative to fossil fuels, but we need also to develop circular and sustainable devices for getting this. Up to now, and this is logical, the manufacturers have been focused in the ergonomy, resilience of the products, and the economy of the products. So, but now it's time to look also to introduce this view at the end of life, and also how to decrease the environmental and social impact along the supply chain of this product. So, I think in this way, the collaboration between Best4High and eGHOST is really fruitful here.
Javier, yeah, thank you for this comment. Maybe if there is no other question, I would maybe just add that eco-design presented today was really focused on the end of life. So where maybe the biggest challenges are currently not just in the LCA modeling, but also with all the critical and rare earth materials recovery. Of course, the eGHOST project deals also with other parts of the eco-design axis. So we are addressing eco-design first in the on the production side. So where the closed loop, of course, of the recycling is linked to the production, and of course the reduction of the masses that should supposed to be in the future of the components is assumed in different product concepts. We will for sure show also the importance of the hydrogen production, because at least to show that maybe all efforts are worthless if we will use gray hydrogen in our technology. So just to show also the importance of this part, so the use phase. And the end of life phase, as said, is from different points. So the closed loop and the open loop. And the open loop, of course, it's the loop that will enable other products, other technologies use the recycled materials from fuel cells and hydrogen technologies with lower impacts than virgin material. So we are addressing all 7 axes, and we are also addressing as many actions as we are possible to apply, because eco-design is structured very generically, and sometimes with some gap of data, maybe you cannot address all the points in all technologies, but more or less we cover all axes with all actions. Of course, this maybe I can also say that the results will be available in the deliverables in the future. And Javier, correct me if I'm wrong, I think that those deliverables should be public so that you will also be able to see the results. And at the end of the project, it will be also a white book that is actually establishment of the guidelines, not just for the LCA practitioners, but for the industry, how the different actions should or will be addressed not just on the environmental part, but also it will be on the cost. So life cycle costing will be also addressed, and also social life cycle. So it will be a sustainable assessment approach that will for sure give more detailed results that would be just from the environmental point of view.
Yeah, just to confirm that all the deliverables are public, and you can find them in our website, in the eGHOST website.
Maybe Jure just switch the slide to the last one, that where we have also our web page. There you can find there many different links of the work done so far. And of course, if you have any other further questions regarding LCA or eGHOST, you can address Javier in IMDEA as coordinator of the project, or for life cycling, you can write also to me, and we will provide you an answer, of course, if we will know your answer. But I think that more or less the models now are established. We are just finishing some parts of the end of life, and the results will be available very soon, and they look promising. Maybe any other question or comment?
I have one. Emmanuel Cor from CA. I'm part of the eGHOST project. You discussed, Misha and Jure, about the scaling up of the LCA data at industrial scale. Could you develop a little bit more how this can be done, and how uncertainties about scaling up can be addressed in this kind of approach?
The scaling, yeah, there is a gap between laboratory level that is now on TRL5 and industry level. Of course, in the case of PEM recycling, where we are aiming for platinum and ionomer, maybe the gaps won't be so big, since Hensel Recycling is performing this task, and they are industry level companies, so they are already taking into account some measures that the mass and energy balances are closer to the industry, let's say, level that that may be just on the laboratory scale. On other side, in the where the recycling is performed really on the chemical level, really on the laboratory level, the issue that we found out, or the challenge, is that more or less energy inputs are usually too big, and that's why the result of the recycling process at the beginning is not so promising in terms of the environmental impacts. The scaling up process, the scaling up is actually not in LCA, it's not the part of the project, so that the scale up, but the models are, let's say, set up in the way that each step is modeled separately, chemically wise. And with the, it is the possibility in the future just adapt the energy inputs and also the mass balances, and the results could be immediately on the industry level. Now the other issue maybe regarding this laboratory level is sometimes also very small masses that are recycled, and also here can be a bit of uncertainty because, you know, with the really small masses, the loss that it is not properly monitored can represent a huge difference at the end, because sometimes in the recycling processes we are dealing with grams of the recycling material that can be but it is not from these results without additional inputs. It's not planned to go with the scaling up just, you know, out of our heads or blind to eyes, but we should get after additional inputs and adapt the models according to that.
Okay, thank you, Mitja.
Just one comment on last. This is about the upscaling, because perhaps simulation can help to have a first idea on how we kind of upscale these processes, just to look, to check the possible profitability and how the environmental impacts are affected by this scaling up. Mm-hmm.
Yeah, for that, for sure. So we can, since we have models really detailed, we can of course scale different inputs and outputs and see where we can get. But of course, this is some kind of scenario analysis that is based just on, let's say, potentials that this recycling process has, but we cannot assure that this will happen, since of course industry has to confirm that this is possible on the industry level. But I agree, Javier, completely. Maybe any other comment?
This is Diego Iribarren in the Energy. I have a question for Mitja and the University of Ljubljana colleagues regarding, as you have said, that the TRL for these end-of-life technologies is sometimes or usually relatively low. What's your opinion about what's the expected alignment between the deployment of hydrogen products and the deployment of end-of-life technologies? Do you think that they will match, or there will be problems when the need arises to recycle and to manage the end of life of these products?
Okay. Maybe I can comment this a bit. Of course, in PEM technology, we are dealing with really critical material as a platinum. Also, ionomer, it seems to be in future, will be very critical material, also maybe regarding future legislation of the Europe Union. We all know that the production of the virgin platinum is quite critical from the environmental point of view. So already on the TRL5 level, the results shows that the recycling is a good solution and will be implemented on the industry level also from the fuel cell and hydrogen technologies. A bit different is on the solid oxide technology, since we don't have the exact databases, generic databases of the virgin materials. I'm talking here about maybe ytterbium, stabilized zirconia, and other ceramic materials. We are very much focused now in establish as exact as possible virgin production of those rare earth materials, but they are a few magnitudes lower on the scale of the environmental impacts on the same mass unit as the platinum. So the recycling of those looks promising, but should be, of course, even more carefully addressed. Because in the recycling, we want to get at the end recycled material that has lower environmental impacts than virgin one. In this technology, I think that the gap between virgin and the recycling will be a bit, let's say, lower than in the PEM fuel cells. But since also the virgin materials are with lower, let's say, environmental impacts, is even more promising from the mass production, maybe as in platinum recycling. And we all know that solid oxide technology now is very high on the agenda of the European Union, and there are also many projects in the future devoted to this topic. So I'm very optimistic also that we will align the recycling process of those materials that will show, let's say, good and promising results. Hopefully I answered your question.
Sure, thank you.
If there is no other questions, maybe Javier, would you add some comment at the end of the presentation as a coordinator of the project, and maybe then we can conclude this live chat if you agree.
Perfect. Yeah. First of all, I would like to thank the Milla and all the University of Vienna team, because they have prepared perfectly this chat. Just as a reminder that eGHOST and Best4High are the first projects just looking at the eco-design. In our case, in eGHOST, and Best4High is the first experimental project in recycling. So as I commented previously, we are just opening the way for future projects and to enhance the sustainability and circularity of the hydrogen economy. All the deliverables for eGHOST, I guess that all the public deliverables also for Best4High will be available in our respective web pages. So you can see now in the screen the eGHOST website is eghost.eu. And just finalizing, just hoping that you have enjoyed this chat and you have a new idea of our projects. So that was all from my side. If there is not any further question.
Hello, I'm Mariana Franchino from Environment Park, coordinator of Best4High, and just would like to thank you for this live chat and the opportunity to discuss about our projects. And thanks again for this strict collaboration that we have. And I'm more from the dissemination activity, so I cannot say much more about the technical side, but Mitya explained it very well, and although discussion was very interesting. And so just my hello to everyone. And again, if you, everything is on our website, all the deliverables and information. And so I look forward for the next meeting and discussion about our project. There are really a lot of work to do, and we are on our way.
Thank you, Mariana. Thank you, Javier. Thank you, Jure, for presentation. And see you soon with new results. Thank you very much. Have a nice day.
Thank you. Goodbye.
Thank you, everyone.
Thank you.
Bye.